AND gate. The AND gate is a fundamental digital logic gate that implements logical multiplication. It outputs high or 1 only when both of its inputs are high or 1. Think of it like two switches that must both be turned on for a light to turn on. The AND gate follows the rule, output equals input A and input B in Boolean algebra. This is represented as y equals A times B or y equals A and B. The AND gate is essential in digital circuits for conditions that require all criteria to be met simultaneously. The truth table shows all possible input combinations. When both inputs are 0, output is 0. When one input is 0 and the other is 1, output is 0. Only when both inputs are 1, the output becomes 1. AND gates are used in digital systems for enabling signals, address decoding, and creating control logic where multiple conditions must be satisfied. AND gate input are set to high. At least one input is low, so AND gate output is low. AND gate input B set to high. Both inputs are high, so AND gate output is high. AND gate input are set to low. At least one input is low, so AND gate output is low. AND gate input B set to low. At least one input is low, so AND gate output is low. OR gate. The OR gate is a basic digital logic gate that implements logical addition. It outputs high or 1 when at least one of its inputs is high or 1. Think of it like two switches where turning on either one will turn on a light. The OR gate follows the rule, output equals input or input B in Boolean algebra. This is represented as y equals A plus B or y equals A or B. The OR gate is used for conditions where any of multiple criteria can be satisfied. The truth table shows that when both inputs are 0, output is 0. But when either input is 1, or both are 1, the output becomes 1. OR gates are used in alarm systems, interrupt handling, and creating logic where any of several conditions can trigger an action. OR gate input are set to high. At least one input is high, so OR gate output is high. OR gate input B set to high. At least one input is high, so OR gate output is high. OR gate input are set to low. At least one input is high, so OR gate output is high. OR gate input B set to low. Both inputs are low, so OR gate output is low. NOT gate. The NOT gate, also called an inverter, is the simplest logic gate with only one input. It outputs the opposite or complement of its input. When input is high or 1, output is low or 0, and vice versa. The NOT gate follows the rule, output equals NOT input. In Boolean algebra, this is represented as y equals NOT A or y equals A with a bar over it. The NOT gate is fundamental for creating complementary signals and logical negation. The truth table is simple. When input is 0, output is 1. When input is 1, output is 0. It completely inverts the signal. NOT gates are used for signal inversion, creating complementary outputs, and as building blocks for more complex logic circuits. NOT gate input set to high. Input is high, so NOT gate output is low. NOT gate input set to low. Input is low, so NOT gate output is high. NAND gate. The NAND gate is a universal logic gate that combines AND and NOT operations. It outputs low or 0 only when both inputs are high or 1. In all other cases, it outputs high or 1. The NAND gate follows the rule, output equals NOT of input A and input B in Boolean algebra. This is y equals NOT A times B. NAND gates are called universal because any logic circuit can be built using only NAND gates. The truth table shows that only when both inputs are 1, the output is 0. In all other combinations, the output is 1. NAND gates are widely used in memory circuits, flip-flops, and as universal building blocks for creating any digital logic function. NAND gate input are set to high. Not both inputs are high, so NAND gate output is high. NAND gate input B set to high. Both inputs are high, so NAND gate output is low. NAND gate input are set to low. Not both inputs are high, so NAND gate output is high. NAND gate input B set to low. Not both inputs are high, so NAND gate output is high. NOR gate. The NOR gate is another universal logic gate that combines OR and NOT operations. It outputs high or 1 only when both inputs are low or 0. In all other cases, it outputs low or 0. The NOR gate follows the rule, output equals NOT of input or OR input B in Boolean algebra. This is Y equals NOT, A plus B. Like NAND, NOR gates are universal and can create any logic function. The truth table shows that only when both inputs are 0, the output is 1. When either input is 1, or both are 1, the output is 0. NOR gates are used in memory circuits, static RAM cells, and as universal building blocks for digital systems. NOR gate input are set to high. At least one input is high, so NOR gate output is low. NOR gate input B set to high. At least one input is high, so NOR gate output is low. NOR gate input are set to low. At least one input is high, so NOR gate output is low. NOR gate input B set to low. Both inputs are low, so NOR gate output is high. XOR gate. The XOR gate, or exclusive OR gate, outputs high or 1 when its inputs are different from each other. It outputs low or 0 when both inputs are the same. The XOR gate follows the rule, output equals input or XOR input B in Boolean algebra. This is Y equals a circle plus B. XOR gates are fundamental in arithmetic circuits and error detection systems. The truth table shows that when inputs are different, 0 and 1, or 1 and 0, output is 1. When inputs are the same, both 0 or both 1, output is 0. XOR gates are essential in adders, subtractors, comparators, parity generators, and encryption circuits. XOR gate input are set to high. Inputs are different, so XOR gate output is high. XOR gate input B set to high. Inputs are the same, so XOR gate output is low. XOR gate input are set to low. Inputs are different, so XOR gate output is high. XOR gate input B set to low. Inputs are the same, so XOR gate output is low. XNOR gate. The XNOR gate, or exclusive NOR gate, is the complement of the XOR gate. It outputs high or 1 when its inputs are the same, and low or 0 when inputs are different. The XNOR gate follows the rule, output equals NOT of input or XOR input B in Boolean algebra. This is Y equals NOT, A circle plus B, or Y equals A circle dot operator B. XNOR gates are used for equality comparison. The truth table shows that when inputs are the same, both 0 or both 1, output is 1. When inputs are different, output is 0. XNOR gates are used in equality comparators, parity checkers, and digital circuits that need to detect when signals match. XNOR gate input are set to high. Inputs are different, so XNOR gate output is low. XNOR gate input B set to high. Inputs are the same, so XNOR gate output is high. XNOR gate input are set to low. Inputs are different, so XNOR gate output is low. XNOR gate input B set to low. Inputs are the same, so XNOR gate output is high.
ये एक मैंने सॉफ्टवेयर बनाया है जो मैंने आपको दिखा दिया इसका रिजल्ट, और इसमें जो चीज़ है वो इजीली एनिमेशन के थ्रू समझाई जाती है। और ये मैंने कोड जो है वो HTML और CSS की मदद से लिखा है, और ये 2205 लाइन का कोड है। HTML CSS में एनिमेशन, अगर ये किसी को कोड चाहिए या ये प्रोजेक्ट चाहिए तो आप मुझे मेल कर सकते हैं, और इस YouTube जो चैनल है उसके जो कमेंट सेक्शन है उसके अंदर भी आप मैसेज कर सकते हैं और उसका रिप्लाई भी दूंगा। बाकी मेरे चैनल टीच लर्न स्कूल को ज़्यादा से ज़्यादा लाइक, सब्सक्राइब एंड शेयर करें। थैंक्स फॉर वॉचिंग। अल्लाह हाफिज़।